Okay, number 2 is similar, but this time we have a difference, so we're going to have to be a little careful. I'm going to go ahead and use my log properties first here. I am still thinking that I want to exponentiate with base 5 to get rid of the logs, but I know in advance the same thing that held over here will be true here. I need to combine those logs before I'm going to be able to eliminate them. If you're subtracting two logs, this is going to be combined into the log of a quotient. Okay, now I can exponentiate with a base of 5. So I'm thinking 5 to the log base 5 of x over x plus 1 equals 5 to the log base 5 of negative 2x. Ignore that. The 5's and the log base 5's both happen one right after the other, so we can cancel all of that extra mess and just say x over x plus 1 is going to equal negative 2x. We have now successfully converted this log equation into a rational equation. If we want to solve this thing, we're going to multiply both sides by an x plus 1. Get the variables out of the denominator. I'm going to go ahead and distribute. I wouldn't want to divide here because there's an x involved. I could lose a solution. So I'm going to say x equals negative 2x squared minus 2x. And then I think I'll move everything to the left. So let's add the 2x squared and add the 2x. Add the 2x. So we end up with 3x. We can factor an x out. And it looks like we're getting x equals 0, or what is that going to be? X equals negative 3 over 2. We have our non-optional check. X equals 0, not going to work for the first one or the last one, so we should throw that away. If it doesn't work for any log in your original equation, you have to throw it out. X equals negative 3/2 actually also doesn't work. It doesn't work for the first one. It doesn't work for the second one. It would work for the third one, but it doesn't matter. So this is actually a no solution. And that's completely valid. That can happen. If you get two solutions, they might both work. One might work. Neither one might work. All of those things are possible. So just make sure you check anytime you start with logs. Okay, so if you end up with too much log mess floating around, remember you can always combine logs using the sum and difference properties, and that's a good thing to do before you exponentiate. Having an addition or subtraction in your equation is kind of your enemy when you're working with exponential or log, really. Neither one of those is particularly nice when you have addition subtraction.